and welcome to slide pack 15 of the financial modeling program. What we will do here is pick up on some of the Excel formulas that we left off on in slide pack 14. So with that, what I'm going to do is now go into Excel. And now some of the other things I wanted to show you purely from a financial modeling perspective is that there are formulas such as a future value formula or a formula for present value or formula for payments. And what I'm going to do first is use Excel's help function and type in FV and see if it searches its database either online or on my machine and comes up with the FV formula as it does. So now if you look at this, it says it returns the future value of an investment based on periodic, constant payments and a constant interest rate. So let's just say you paid $100 on the 1st of Jan for the next 5 years. And the interest rate was, let's just say 10%. Then what this formula will give you is the future value of your income stream or of your cash payment stream at the end of your period, the future value. Now, if you look at the syntax, it says within parentheses, the first thing that this formula needs is, and I'll highlight this, it needs the rate. So the rate is basically the interest rate per period. The second thing it wants is the number of payment periods in this situation that you're talking about. So if it's 5 years, you'll enter in a 5. If it's 3 years, you'll enter in a 3. Payment is the payment made each period, so $100 or $2,000 or whatever. I mean, the number can be whatever you want it to be. Now PV is something that I'm going to skip over for now. And the fact that it's not highlighted in bold tells you that it's an optional parameter. You need not enter this. And then after that, it's got something called the type parameter. And it says that it's the number 0 or 1 and indicates when payments are made. So if we look at that, a 0, or if you omit it, it's assumed to be a 0, is when payments are made at the end of the period. So if we're standing on the 1st of Jan, let's just say 2011, then it assumes that our first payment of, let's say, $1,000 is made on the 31st of December. It's made at the end of the period. The second payment is made on the 31st of December 2012. And so if you give it a time scale, it basically assumes that the payments are made at the end of each period. And it gives you the future value for that payment stream. On the flip side, if you make your payments at the beginning of the period, so if you give your first payment on the 1st of Jan and the second one on the 1st of Jan 2012 and so on, then the formula is going to calculate a slightly different value. So this is the future value formula. And if we go in here, what you'll see is I've just done a very simple one where I've said FV equals, I've made a reference to cell C1. Cell C1, as you can see, is 6%, which is the rate of interest. And then if you just move your cursor within the parentheses, Excel has this little handy tool where it'll actually tell you what it's expecting. So then after that, I say, okay, the number of periods or the number of payments is 4. And then I say that the payment I'm making, and you know, when you're giving out money, you just, the way Excel set up, you just stick in a minus sign before that. So I say, okay, it's $100 that's going to leave my pocket, so it's a minus 100. Then I am not interested in specifying the PV, so I stick a 0 there. And then I say 1. Now by saying 1, what I'm saying is that I want the payment to start at the beginning of the period. So Excel says fine, and then it gives me a value of 463.71. Now, if we move over here, you look at the first payment of $100. That's happening on the 1st of Jan 2010. The second one happens on the 1st of Jan 2011, the third in 2012, and the fourth on the 1st of Jan 2013. And when you look at the future value of all of these at growing at a rate of 6%, you get not 400, but you get 463.71 because of the compounding that happens at a rate of 6%. Now, what I want to show you here is that Excel also gives you enough arithmetic power that you can do some of these calculations without using Excel formulas if you want to. And I typically tend to do this just to make sure that my NPV formula is correct. And I'd rather use formulas because then I know Excel is going to do the math correctly. But that said, I'm always careful on the various parameters within the formula, and I'd sort of advise you to do the same. So what I have done here is I've said, okay, I started out with $100. Now, after 1 year, that $100 amount of mine, and before I go into that, I'm just going to increase the font a little if it'll let me. So after a year, I've earned 6% interest. So my 100 has grown to 106, and the formula I use is equals C3, which is the $100 payment amount, multiplied by 1 plus the 6% rate. So 1.06 times 100. Then what I say is, okay, by Jan 2012, it's grown another 6% compounded to 112. By Jan 2013, it's grown to 119. And by the end of my 4-year period, it's grown to 126.25. Likewise, I start out with my second payment, and that grows to 119. Long story short, when I add all of these up, it gives me 463.71, which is exactly the value that I get from the Excel formula. Now, that was using FV, future value, with a parameter of 1. Now here, what I've done differently is I've used future value with a parameter of 0 to indicate that the payment was made at the end of the period. So here, the payment doesn't come in on the 1st of Jan 2010, but it actually comes in on the 31st of December 2010. And I've sort of ignored that 1-day period, and I've just sort of said, okay, my first payment really comes at the end of the first year, which is, let's just say 31st December or the 1st of Jan, and so on and so forth. And then that gives me a slightly different value. So what I'm trying to highlight here is that if you have beginning of the period compounding, then you compound a lot more and you get a value of 463. But if you have end of period compounding, you lose out on compounding because there is no money for the entire first 12 months, and the money comes in at the end of the period. So consequently, the future value formula returns a slightly lower value. The important thing here again is that you have to make sure that you understand the various parameters within your Excel formulas. Now, another thing that I want to briefly talk about is that you can always have a formula that says equals 100 divided by. Now in the divided by, you can actually do a lot of things provided you take care of your parentheses. So what I do is I first stick in a pair of parentheses, which Excel doesn't like, and then I take my cursor back in and I say I want it divided by 1 plus the interest rate, and now this caret sign is to the power, and I'm going to say to the power of 5. And now everything below the divide by slash is within closed parentheses, so I know that I'm just sort of making sure that the math doesn't screw up by making sure everything is within parentheses. So, and I enter, and that gives me a certain value. So what I wanted to actually highlight here was basically how you can use the caret sign to do something to the power of within Excel. Now, there are other formulas that are also very important from a financial modeling perspective. There's a present value formula, which is the PV formula. And what the PV formula basically says is that if I have a bunch of payments that I'm going to make every year, what is the present value of those payments? So let's just say I give a friend of mine $100 on the 1st of Jan 2010, and another 100 on the 1st of Jan 2011, and another on the 1st of Jan 2012, and my final $100 goes to him on the 1st of Jan 2013. Now, if I commit to making this payment stream to him, what is the present value of this payment stream? And so Excel's present value formula, which is PV, and here if I click inside, it says first I want the rate, then I want the number of periods, next I want the number of payments, and then optionally you can tell me the FV and you can tell me the type. So now here I say, okay, the type is 1. Now every time the type is 1, that means that the payments start at the beginning of the period. So Excel says, okay, fine, the present value works out to $372. What this basically applies to in financial models is that if you have a bond, or if you have like payments of interest going out and with some lump sum principal to be paid out at the end of 5 years or whatever, you can actually use the present value formula to determine the value today of a future stream of payments, which is how bonds are calculated in financial models. So let's just say you have a formula where you have to issue out debt. You can use the present value formula. Now there's another formula, which is the NPV formula, the net present value formula. And what I'm going to do here is go into Excel's help feature and type in NPV, and there it is. It gets the NPV. So let's look at the NPV formula. It says, okay, tell me what the rate is, and then give me the different values, up to 29 different values, and I will tell you what the net present value is today. Now, further, it says each of the values must be equally spaced in time and occur at the end of each period. So in the NPV formula, there is no type parameter, but Excel tells you the payments must be made at the end of each period. And then NPV uses the order of value 1, value 2, etc. to interpret the order of cash flows. Arguments that are numbers, empty cells, logical values are counted. In fact, let's just skip this and go straight to a formula. To an example. So if you look at this example that we have here, it says equals NPV. A2 is that rate of 10%. A3 is the payment amount, which is negative 10,000. A4 is the next payment amount, which is 3,000. A5 is the next payment amount, which is 4,200. A6 is the other payment amount, which is 6,800. Now, what you can do is you can also have negative payments in here. Not just the first one, but for example, your fifth payment can be a negative payment. And then what this will do is this will tell you what the present value is at a 10% discount rate of these payment streams. So the difference between the future value or the present value formula and the NPV formula is that the NPV formula allows you to put in up to 29 numbers that are different from each other, whereas the future value and the present value require that the payment made every period be identical. Now, when you're doing a discounted cash flow valuation, we all know that your various cash flow streams are not going to be equal. So for example, the cash flow in year 1 is not going to be the same as the cash flow in year 2 or year 3 or year 4 and so on and so forth. So you cannot use a present value formula to understand what the value is as of today. You have to use an NPV formula. So what you just saw here is the NPV formula. Now the other thing you can do in Excel is you can actually go in there, and in fact let me try and do this. What I'm going to do here right now is I am going to say, okay, that my first payment is a negative 1,000. My second payment is 512. Where that? My third payment's going to be 600. My fourth payment is going to be negative 100. And my next payment is going to be, let's just say 200. Now I've got these 5 cash flow payments, and I'm going to say equals NPV, and NPV, and I'm going to specify a rate, and I'm just going to say 0.1, which is the same as 10%. And then what I'm going to do is I'm going to highlight the cells where I've got the values, and then I press enter. So Excel doesn't want you to necessarily enter each number. You can also highlight the cells that have the various values, and then it discounts all of this back to today, and it says, okay, the NPV at this rate is 20.72, assuming that the payments are made at the end of each period. And now let me go in here, and if you remember, the rate I used was 10%. So I'm going to say, okay, this is at the end of year 1, this is at the end of year 2, this is at the end of year 3, 4, and 5. Now, the present value of this is 1,000 divided by 1.1 for 10% to the power of 1 year. And likewise, I am going to copy this over. So now what I have here, and I'm just going to make it slightly pretty, I've just get rid of. So what I have here is a sum of the present values of these various payments that happen at the end of each year. Now, if I take the sum of these, I get a value of 21.72, and if I just sort of have that in dollars, you will see that 20.72 is exactly the same as the NPV formula. So the NPV formula is a very nice formula to have. It saves you the trouble of doing all this Excel math, and you should definitely make that your friend, specifically for financial modeling and financial projections. Now, one last formula I want to share with you before we leave is the PMT formula, or the payment formula. Now, this is something, so if you think of basically a stream of payments, in fact here, this is the present value. I'm sorry, here, let's just go down to the payment formula. So the payment formula basically says that I want the rate, and we specify here that the rate is 5%. And actually, I don't have the data on this one, so what I'm going to do is I'm just going to stop here. We don't just bear with me for a second here. Some confusion, my apologies. Okay, here we go. So this is a payment formula, and the payment formula says give me the rate, give me the number of periods, and then basically give me the present value of something, and I will tell you what the periodic payments need to be for that. So let's just stop here without going into any details, and this hopefully should give you a fairly comprehensive set of functions that you can use in your financial modeling program. And with that, we will conclude this slide pack. Thank you very much.